Let us have the logarithm for indefinite integrals. So let us evaluate number 1, the integral for 2 dy over 7y plus 4. So to get the derivative of the denominator, which is 7y plus 4, that is equal to 7 dy, since 4 is already 0 if you're going to get the derivative for that. So for this one, if let us just rewrite first. Let us bring out 2 there. That is the integral of dy over 7y plus 4. So that is equivalent to. So since the derivative of 7y plus 4 is 7 dy, it doesn't satisfy the numerator here. So that is to be manipulated again. So let us multiply it by 7 and then divide it by 7. Okay, manipulating that, it will give us 2 multiplied by 1 over 7, the integral of 7 dy over 7y plus 4. Since the denominator 7y plus 4, to get the derivative for that, it is 7 dy. So it satisfied already the numerator. So let us just simply get the logarithm for that. So that will become 2 divided by 7. And then the integral for that is the logarithm, the ln of 7y plus 4 already. So plus c, that is our final answer. Next, evaluate the integral for 2x minus 5 dx over x squared minus 5x plus 3. So let's get the derivative of the denominator, which is x squared minus 5x plus 3. So that is equivalent also to 2x minus 5 dx. So since the numerator satisfied this one, let us just get the logarithm for that. So use the formula for logarithm, that is equal to the ln of the denominator, which is x squared minus 5x plus 3 plus c. So that is our final answer. For number 3, let us evaluate this one. The integral for 1 plus 2x squared. So let us expand first. 1 plus 2x. Okay. So that is equal to 1 times 1. There, the 1. That is 1 plus. So 1 times 2x. So that is 2x plus. This one, 2x times 1, that is plus 2x plus 2x times 2x, that is plus 4x squared. Okay, simplifying that further, that will become 1 plus 4x plus 4x squared. Okay, so rewriting the equation, that is also equivalent to the integral of 1 plus 4x plus 4x squared over x dx. Okay, so let us distribute x now. That is dx over x plus the integral of 4x over x dx plus the integral of 4x squared over x dx. Let us simplify this further. It will become the integral of dx over x plus, for this one, let us cancel x, that is the integral for dx plus, so this one will be cancelled, and what remains there is the x, so that is the integral of 4x dx. Okay, we are now ready to integrate that one. So for this one, for the first term, the differential for the denominator, which is x, is simply as dx. So let us get the logarithm. Okay, so that is the ln of x. Okay, so for the remaining, those are just power rule. So that is 4x plus 4x squared over 2 plus c. But we can simplify this. So that is ln of x plus 4x plus 2x squared plus c. Okay, next. evaluate this one, the integral for tangent x dx. So let us recall your trigonometric identities. Your tangent is equivalent also to your sine divided by the cosine. So rewriting the equation, that will give us the integral for sine x over cosine x dx, and be mindful that the derivative of your cosine x there is equal to negative sine x dx. Since your numerator here is a positive sine x dx, and the derivative of the denominator is this one, negative sine x dx, let us manipulate again since this is in negative. Okay, so let us multiply and divide it by negative. So rewriting that one, manipulating the equation again, that is negative integral of negative sine x dx over cosine x. Okay, since negative times negative, it is positive. It will arrive at the same original equation. So that is equal to the ln of cosine x plus c. So that is our final answer. Okay, example number 5. Let us evaluate this one. That is the integral of x cubed dx over x minus 1. Let us just simply divide this. So that is x cubed divided by x minus 1. So don't forget your algebra. So we are going to multiply their x squared, so that x cubed will be cancelled. X squared times x, that is x cubed minus x squared. Then let us subtract. That is negative, and this will become positive. So this one will be cancelled, and then what remains there is the positive x squared. So to be able to eliminate x squared, let us multiply it by x. Okay, so x times x, that is x squared minus x. So subtracting that again, this will become positive, this will become negative, and this one positive. Okay, so what remains there is the positive x. Okay, to be able to eliminate x again, let us multiply it by 1. So 1 times x, that is x. 1 times negative 1, that is negative 1. And then subtracting it again, it will become negative. This one positive. Okay, so the remainder is 1. So if we are going to rewrite this one, that is equal to the integral of x squared plus x plus 1 plus the remainder, which is 1, over the dividend, which is the x minus 1. Okay, that is dx. Let us just distribute dx there. Okay, so that is x squared dx plus the integral of x dx plus the integral of dx over x minus 1. Okay, so for the first term, let us use power. For the second, let us use power. And for the third term, let us use logarithm, since the differential for the denominator is the numerator here. Okay, so that is equal to power rule, that is cube, over 3 plus x squared over 2 plus the ln of the denominator, which is x minus 1 plus c. Don't forget the arbitrary constant. Okay, that is our final answer. Next, evaluate the integral of e raised to x dx over e raised to x plus 1. So to get the derivative of the denominator, of course, the Euler's number, it is the same. That is e raised to x dx. Since the derivative for this one satisfies the numerator, so let us just use logarithm in getting the integral. So that is equal to the ln of e raised to x dx plus c. That is our final answer. Okay, so for example number 7, let us evaluate the integral of d theta divided by sine 2 theta. So don't forget that the trigonometric identity for cosecant is 1 over sine, whereas for the secant, that is equal to 1 over cosine. So rewriting the equation, that is also equal to the integral of cosecant 2 theta d theta. And for this one, let us just multiply by its conjugate, which is cosecant plus cotangent over cosecant plus cotangent, or for secant, that is multiplied by secant plus tangent and over secant plus tangent. So cosecant, it is partnered with cotangent, whereas for secant, that is tangent. So they are partners. Okay, so multiplying this one by its conjugate, that is cosecant 2 theta plus cotangent 2 theta divided by cosecant 2 theta plus cotangent 2 theta. That is d theta. Okay, so multiplying this one, distributing cosecant 2 theta, and let us just remove the d theta there since we have it already. Okay, so that is equal to cosecant squared 2 theta plus cosecant squared, no, that is cosecant 2 theta cotangent 2 theta. Okay, what remains there divided by the denominator cosecant 2 theta plus cotangent 2 theta. That is in d theta. That is the integral. Okay, to be able to get the integral for that, let us get the derivative of the denominator. For cosecant 2 theta, that is equal to this one, negative cosecant 2 theta, cotangent 2 theta, and then for the derivative of 2 theta, that is 2. And then for cotangent squared, cotangent 2 theta, that is equal to negative cosecant squared 2 theta 2d theta. So for the numerator, that is in positive and that is multiplied by 2, whereas for the differential, that is in negative and 2. So we are going to divide it by negative 1 half and multiply it by negative 2. Okay, so manipulating again the equation, that is negative 1 half. Copying that, that is cosecant squared 2 theta plus cosecant 2 theta cotangent 2 theta, multiplying it by negative 2 d theta. Okay, so divided by cosecant 2 theta plus cotangent 2 theta. Since the denominator, the differential for that is the numerator, let us just integrate that one using logarithm. Okay, so for our final answer, that is negative 1 half the ln of the denominator plus cotangent 2 theta. Okay, plus c, the arbitrary constant. That is our final answer. Okay, so let's move on to example number 8. That is a hyperbolic tangent, and the identity for hyperbolic tangent is equal to that of the trigonometric identity. So let's rewrite that one. It will become sine h hyperbolic sine 7x divided by cosine hyperbolic, that is hyperbolic cosine 7x dx. So getting the derivative of the denominator, which is cosine h 7x, that is equal to sine h 7x times 7dx, since the derivative for 7x is 7dx. Okay, so let us just get the logarithm for that and let us manipulate, since the numerator has 7. So let us divide it by 7 and multiply it by 7. Hyperbolic sine of 7x divided by hyperbolic cosine of 7x, multiply it by 7 dx. Okay, getting the integral for that, that is 1 half the logarithm of the denominator, which is cosine h 7x plus c. So that is our final answer. Continuing that, let us have example number 9. Evaluate this. The integral of y dy over 25 plus y squared. So solution for that, since the derivative of the denominator 25 plus y squared is equal to 2y dy, our numerator there doesn't satisfy this one, the derivative. So let us manipulate it by dividing it by 2 and multiplying it by 2 again. Okay, so that is 1/2 the integral of 2y dy over 25 plus y squared. So, getting the derivative, getting the integral, that is 1/2 the ln of the denominator, which is 25 plus y squared plus c. So, that is our final answer. Okay, for our last example, let us evaluate the integral of y cubed dy divided by 25 plus y raised to 4. So, the derivative of the denominator is 25 plus y raised to 4 is 4y cubed dy. Since, again, the derivative is this one and it doesn't satisfy the numerator, let us manipulate again by dividing it by 4 and multiplying it by 4. Integral of 4 y cubed dy, since 4 divided by 4 is still 1. So we will arrive at the same original equation, plus y raised to 4. Okay, so that is 1/4 the logarithm of the denominator, which is 25 plus y raised to 4 plus c. So that ends our logarithms for indefinite integrals.